can't say anything's terrible.
Yeah. No swearing.
So I always thought they're not for kids things, so I can swear as much as you like. I'm going to zoom in. I am actually video. This is Chris and this is Giles from Beckhoff, and we're also going to go wander over because there's a couple of demos. This is the LabVIEW demo. I would say this is the British demo. There's a German demo over here. Exactly.
Needs wiring. This is the one that didn't work live on stage. That's this demo.
Nothing ever works live on stage.
No.
That's expected.
It worked as soon as I walked outside.
So this is Beckhoff. So Beckhoff make lots of nice hardware. TwinCat is the system, EtherCat is the protocol. I highly recommend people learn this because I think it's very, very useful for designing systems. And, so I can zoom in on over here. I like things that have space to do cabling. So these cabling solutions, again, the space, which I like. So tell us about TwinCat and tell us how. It's my very fake loaded question. How can I make a very safe system with TwinCat, Chris?
Okay. So TwinCat is Beckhoff's operating system and development environment. So Beckhoff is a PLC manufacturer. We work in the automation, packaging process, food industries across the board. And we've made a number of solutions that facilitate that, basically. This demonstration was part of my presentation that I gave on day one, where I had network issues, so it didn't work, sadly. But there we go. And effectively what this was designed to show was a real project that we actually worked on with a customer using LabVIEW with TwinCat. And what they needed was to have their measurement bus and their motion control and their safety done in as efficient a way as possible. Okay? And the solutions that we came up with were obviously Beckhoff, because that's who I work for. But they could have been done open source, third party. EtherCat masters exist. There are open source ADS communications that exist that can work for LabVIEW, so you can do all of the stuff that we did here without Beckhoff involved, should you wish to. Okay, it's just that I work for Beckhoff, therefore, strangely enough, I use the Beckhoff IPC.
Has to also integrate, the work part of the project was it had to integrate to existing NI infrastructure that was based on EtherCat.
So the issue they had with the NI implementation was the NI system doesn't support oversampling with distributed clocks. That's an EtherCat functionality. So what EtherCat brings to the table is a single network that allows you to synchronize all the devices on that network together, and therefore you can have really precise timestamps to gather inputs and really precise control of when outputs are set in a system. And it's down into the sort of nanosecond range that you can enforce that control. So EtherCat started off for Beckhoff as a really easy way for us to do motion control. What it's become is a really easy way to do safety and a really easy way to do measurement. Because one of the things EtherCat brings you in the measurement space is it gives you really precise temporal resolution on when you gathered an input data point. So your timestamp is nanosecond accurate for that in a field bus network.
Nice. And talk, I mean, I do a bit of control. I do a lot more measurement, throughputs and channels, and
so EtherCat's an Ethernet-based protocol, so like Prof and Ethernet IP, which means you've got 100 megabit per second. Right? There is a development moving up to gigabit, so we're going to increase that throughput now. But you're talking, we have running systems now where you're exchanging gigabytes per second of data over EtherCat networks, running motion control systems and vision systems and so on. So the amount of data you can push for EtherCat is enormous. The amount of devices you can have on a network has a theoretical limit of 65,000. Because there's a 16-bit counter in there that's unsigned that someone put in the development of EtherCat that would limit that amount. However, no one has ever built a system that size. Even Beckhoff, the biggest system we ever built was 10,500 devices, and that's devices, not channels. So each one of these terminals would be a device that could then have 2, 4, 8, 16 channels on it, So 65,000 would be your device limit, and then you could multiply that by the number of channels that you would then have available to you.
Yeah. I think any more is greedy, isn't it?
Yeah.
Any more than 10,000.
Yeah, you're just getting silly at that point. Yeah. So but the important thing for the question that you asked for is that EtherCAT is also safety rated. So there's a thing called FSOE, so fail-safe over EtherCAT. So EtherCAT itself is a TUV safety rated protocol.
Okay.
So we can exchange over the same bus that you're exchanging your measurement and your motion data, we can just exchange safety data. Okay. And that allows, and that's just EtherCAT, that's not Beckhoff, that's just EtherCAT. Okay. And that allows us, from our offering of devices, to implement these yellow terminals you can see here.
Yep.
So those are themselves SIL3 PLE rated devices that give us safe control of contact, safe inputs, safe outputs. And there's a safety controller that sits here that we then program with our TwinSafe editor, which is a safety, itself a safety rated editor. It's a graphical interface that allows you to program your safety logic. Just to bring it up here. I've got a very, very simple example that I use to show on stage, which is this very simple e-stop. If I show the online data, you can see the two channels coming in from my e-stop here.
Hold on, let me zoom in. I should, as a professional video person, I should have stopped making noises when I zoom in.
You only add them later in sound effects, so you can do it yourself now. It's gonna,
I've done this since I was a kid.
Yeah. Noise the hell out of my wife. Everything comes with its associated noise.
Got the two channels coming in, the single channel coming out, which is controlling the contactor. So if I drop the e-stop in, you can see that.
Lovely.
Yeah. And then we can reset and clear. The important thing about this is that while it is all together on this rack, the system, because of EtherCAT, can be distributed.
Yep.
So instead of having to run all of your cables back to a central safety place with your single safety controller somewhere, you can put that terminal 5 kilometers away from the controller on an EtherCAT network and have it next to the thing you're trying to control and run that back over EtherCAT, and it's TUV SIL3 PLE safety rated.
So I'm really getting into sort of distributed, localized systems that are, you know, so cutting down on wires going into a central location. And because it's particularly for this type of design, the safety side, you want it simple.
Yes.
You want it local and simple, you know, because I always think complex safety is bad safety. You know, if there's too many ifs and ors in the logic, then that's where the accidents happen. It's much better go, you know, cross this laser line, everything powers down.
That's it.
And that's your logic. And, you know.
So you might imagine if this was in our central control system, this unit, and this one here with these inputs was then could be. No, you're right.
Point again.
So imagine if this unit were here was in our central cabinet, for example, with the controller and some local e-stops on the cabinet itself. This one could then be distributed on standard copper with EtherCAT, 100 meters, on plastic fiber 2 kilometers, and on glass fiber 20 kilometers away from that. Yeah, if you wanted to, and then that could then take e-stops that would then be valid in the same safety system, and the only connection would be that.
Very, very nice. That's what I like. So, from a LabVIEW perspective,
and TwinCAT, you do a clever trick with you have two systems. So you can have your PLC on the same controller, and on a different part of that PLC you could be running LabVIEW and acquiring data.
Yeah, I mean, from the Beckhoff perspective, we will quite happily work with LabVIEW at a number of levels. So obviously you can see here on our controller running an NI9145 chassis. You could easily run our hardware off a compact Rio with its EtherCAT master.
Yep.
Yeah, that's no issue. What I was trying to demonstrate here before my network failed, because I used a virtual machine in a live demonstration, was that you can run. We have a system called ADS, which is a protocol for non-real-time systems to communicate with our real-time environment. Okay. So you can think of it like OPC-UA in that regard. It's a TCP-based client-server model.
Nice.
That allows you to pull information out of the TwinCAT system or push it back into it if you want to put some control or some parameterization, etc. into the system. And that's what I was going to show, but my VM decided to have a day off. And what I've got here, what we've made, is using...
Right, we're recording again, and the battery went fucked. Just to explain, if we miss a bit of the conversation, that's what's happened. I'm such a professional.
Quick recap.
So I'm looking closely at code. So there's code that's been written, and
yes, not well.
So this is
it was me, my code.
This is the ADS, which is talking to the EtherCAT, pulling data off of.
Exactly. So what this system has here is a TwinCAT project running on this controller over there on the left, and all it's got in it is the EtherCAT networks synchronized together, running data to a number of terminals, so analog ins, the safety obviously, and this motion terminal here which drives this motor. And that's what all TwinCAT is doing. I think I did some demos for people yesterday, but all this is running is a counter, so there's no hidden stuff going on in the background. What we've then done is tied LabVIEW directly to the EtherCAT master inside TwinCAT. Okay, so all TwinCAT is doing is providing the functionality of EtherCAT, and then it's just sat there idling apart from that.
So, just so I can cover my remit, which I failed miserably on, a LabVIEW project with all this hardware, are there any large ones that you can talk to about that I think won't get you shot by security? In generic terms, just to give the...
Yeah, I mean, we've obviously got, there's a couple of large projects we did, certainly that we've done for, that I talked about yesterday. They were quite sanitised, but they were large-scale projects that that needed, as I said, distributed EtherCAT. There's a number of people that have done sort of at the CS Lug user group. Kevin from Williams did a talk about using TwinCAT and LabVIEW together.
And what type of things they do? Are they measuring and controlling?
That was a control. That was control system and measurement. So what he'd done there was he had a load of EtherCAT devices that the Compact Rio couldn't use for various reasons. With the sort of optional extra parts of the standard they hadn't implemented. Yeah. And what he did was he interposed a Beckhoff PC in between the Compact Rio and the EtherCAT network. Our embedded devices have an EtherCAT slave interface on them, so they can themselves be a device to a high-level EtherCAT network. So he used our device to run the EtherCAT he needed, and then compiled all that into a set of structures that he pushed up to the Compact Rio via an EtherCAT interface.
So, barring the hardware, can you describe actually what what problem the job was trying to solve?
Basically, it's a real-time control system for some dirty, great, big fans. I think that's reasonable.
Yeah. So this is a wind tunnel control system.
Might be.
It's Formula One. They wind tunnel a lot.
Yeah. So, but then there's, as you can imagine, enormous quantities of transducers, enormous quantities. And it gave them the opportunity to take a legacy project primarily developed in LabVIEW, to then integrate new features of new bits of hardware whilst maintaining that EtherCAT backbone and having their LabVIEW as their GUI, which gave them, because that's where, if you blend the two systems together, the LabVIEW front end is still an incredibly powerful addition. So LabVIEW developers getting into EtherCAT can blow people's minds with what they can do on a front end.
I mean, for me, the designs that come into mind is distributed control. That's cool, because that's really across a largish area, so it's large distributed control systems. And like you say, you've got the LabVIEW stuff, the user interfaces, data collection, talking to databases and pushing data around, and that works very nicely. It keeps each bit simple and specialised. I'm a big fan of having things do what they should do. So you use the right tool for the job. So PLC, I really like for safety. I think that's, you're covered as an engineer. If you use ladder logic, for example, or one of the things and say, I've done everything I can, I've done my due diligence, this is a safety relay, this happens, I'm safe, the system shuts down. Data acquisition, I'm using something that the company's interested in data acquisition, they're going to be making it better. The EtherCAT side's interesting because where you say it's 100 meg and going up to a gig, but Ethernet hasn't stopped, so you've got space in the years to come to get even better. I'm already working on systems that's it's got 10 gig Ethernet.
The
hardware's out there.
Absolutely. The ETG and Beckhoff have plans to develop the 10G EtherCAT compatibility and put it into the standard.
And because you're using a standard that's still getting better, you ride on the back of that.
I think if the HMS, the guys make any bus, they make couplers that allow you to transfer between CAN and Profi bus to Profinet and so on. They did a survey that they published where they actually show the growth of the industrial field bus protocols. And the Ethernet based protocols, EtherCAT, Profinet and Ethernet are just a wide Canon Profibus and Modbus are just disappearing from that pool of options effectively.
I use them now and begin to I use Ethernet everywhere as my go-to. It's more recoverable, it's outside of the hardware of the system. The thing I hate about USB systems and the like is and NXI type systems is that they are part of the computer. So if they go wrong, the computer and you can't recover. So with Ethernet type stuff, if it loses the thing it's talking to, you can just ping it until it comes back and then reconnect again. So you can always recover it, maybe you don't have to turn LabVIEW off and turn it back on again.
That's
even down to turn the with the NXI, you have to turn the computer off and turn it back on again.
That was the last 5 minutes of my presentation on the first day. Just trying to make the network come down. Absolutely right.
It's hard before you start. But this is where we want to be. We want to be doing hard stuff.
But the advantage of systems like ADS in this particular instance, OPCUA and so on, is that you could have thousands of those devices all controlled by a central device or a central LabVIEW computer somewhere that's talking to all of them across a distributed network. They then themselves have distributed EtherCAT networks to make sure your time synchronization is linked across all of them. And then, so if you've spoken to Anton from Angara at all, he's actually done this already. He has a central computer and he's got 20 Beckhoff PLCs synchronized on a network that are all talking back to his central LabVIEW application.
I failed miserably in capturing projects, which was much out there, you just don't get time. I don't think it's going to get worked up. Okay, so that's really cool. I like all that. So Beckhoff, if you're interested in designing, you do hands-on events, you do very open.
We're at the Sheffield, the northern lug of the Sheffield event in October, I think it is, 17th. So we're going to be invited to go speak up at that. It's the next one.
We'll be doing training as well, which is get people up to speed with what does EtherCAT look like, what's TwinCAT look like, how does LabVIEW work. We've got 8 licenses for LabVIEW, so we can actually run.
Come to the office. Come to the office and have a play with some hardware.
And I don't think you have an automated support system there. So you've got this very old-fashioned support system where people ring in and they find a human who knows what they're doing.
Well, we know what they're doing. We'll answer the phone.
Even when you say that gives me much more of a warm feeling than.
Well, exactly. And it doesn't matter who you are. You can be a student or you can be head of development at Rolls-Royce. The key thing is you're going to have an opportunity to talk something.
Well, I mean, we're all of us designing bespoke systems. So if I pick up your hardware, it's the first time. I designed a system, maybe even with your hardware. That's the first time I touched anything. So there's a whole world of fear there. Potential sackings and things like that go through your mind if it goes horribly wrong. And again, the cost of the hardware may be higher than just buying a PC, PLC wherever. But the benefit of having people you can speak to in local areas even that you go to is well worth that cost, because the hardware costs get forgotten after a year. But and a crappy system that doesn't work very well with shit software. That's remembered. It sits on your CV forever.
But I think the key thing also is that as a developer that worked with LabVIEW, one of the things that really struck me was you can get up and running for very little cost, right? If you want to play with a few I/O points, you want to play with an entry level IPC, and then there's a CX7000, which is a few hundred euros. It's under 200 or something.
Yeah.
Right. Then you can stick a bunch of I/O modules on the side of it, and then you can be working straight away. Or if you want to, you just download it onto your laptop. Every single license that Beckhoff do is free, bar MATLAB, for development. Right.
Yes, and you've got simulation as well, haven't you?
Yep. So you can experiment with stuff, get stuff working, and there's no cost, no risk. And if you find out, I've got to get into another, to solve my application, I need that other toolkit. Download, run. I don't know how to use this properly. Pick up phone. I'm struggling with toolkit so and so. I've got so far. Can you help me? That's all part of the support structure, and you haven't spent any money yet.
Yeah. No, it's a good sales thing, I think. Well done, boys.
Before you turn it off.
I'm filming.
Yeah. That's the two channels coming in from the safety.
Yeah.
The input. That's the safety output. So I drop the contacts off. You can see the channels are gone. Safety's off. Bring the e-stop out. Hit the reset. Safety's back in. All in LabVIEW. Just to prove that
I'll tell you what, now I'll just get Giles to do that because there was an argument.
Oh, sorry. Just to prove that my demo works. So I've got the e-stop goes in.
E-stop's in.
Lost the channels.
Right, e-stop.
Wait a minute.
Have you let it back out again?
I have it out.
Okay.
Marvellous. Right.
Push it in. There you go. Literally.
Do we need to do a reset?
Yeah.
Reset on it. There you go. Yeah, we can do a reset. Right, ready to go again?
Yeah, go on then.
So push in e-stop.
Yeah.
There you go. That was off. So the output, that's the feedback from the contact, telling the contact is open. Yep. So if you pull the e-stop out, channels come back in, and then reset. There you go.
And there's the contact.
Safety reset.
We're on. Yeah.
And we could control that from LabVIEW as well. We could do the buttons.
Do it back the other way.
Error acknowledge and run stop and stuff could come in from LabVIEW if we wanted to, but just to prove the demo did actually work.
Brilliant.
And obviously same works for motion, same works for, we can...
Just want some actual video evidence somewhere of it working.
Another little pointer, which I found very interesting.
You point the hardware now.
Yeah, the pointers and hardware is that effectively we're now controlling all of this NI EtherCAT without having to have a real-time license. So you can actually do all
okay, yes.
because you're just doing it through the Beckhoff license, which is the
Beckhoff IO license.
IO license. Yeah.
So that is just an EtherCAT chassis then, isn't it?
That's an EtherCAT chassis, yeah.
That's the 9-1. Yeah, 9-1.
Yeah, so I think inherently that's worth thinking about because you've now got access to EtherCAT on NI modules without having to have a real-time environment.
Well, I think we've managed to bully NI into taking industrial communications a little bit more seriously. Well done, Rich. So it's certainly quite a long way up their list of things that they're going to either try and, I know Norm was talking about releasing a lot of the IPNet stuff, and that's beginning to sort of get us along the way of having a very much better experience, shall we say? With the EtherCAT stuff, because of the NI aspect, like you say, has the optional stuff not on it. Which is worth bearing in mind, but it's also we're at a position where hopefully next year or the year after that's going to be all sorted. And it's one of those things, I guess, it's a lot of requirements that 95% of jobs are reasonably simple. Whereas
I think the big thing with EtherCAT, and the reason I would always push it so much, and there's obviously some element of competition between Beckhoff and NI for things, but sort of taking that hat off for a bit and just thinking about it sensibly, the thing with EtherCAT is it's an open standard, unlike the other Ethernet-based protocols, which means that if you look at the user groups, the people that develop devices in the networks, there's less than a couple of hundred for each of them. Ethercat is over 7,000.
Yeah.
Manufacturers making devices, making masters for that network protocol. So you don't have to use a Beckhoff Ethercat master. I would want you to use a Beckhoff Ethercat master, right? You don't have to use, and there's open source ones, there's third party ones, and the amount of I/O that you can get from anywhere. So it gives you this. You can, if you can't get this 32-channel analog input from Beckhoff, you can go to SICK or IFM or Beckhoff or anyone. It opens you up to a world of a huge ecosystem of manufacturers that are all producing devices for it, and they're all producing couplers to the other protocols. So Ethercat is fast enough that it can run Profinet, Ethernet IP, CAN, Profibus as a sub-bus to itself. So using that one gives you all the other ones by default, effectively. And I think that was what I was trying to explain to yesterday in the huddle about it. I was like, it's much bigger than the others because it has this flexibility. It's not one manufacturer pushing it. There's a lot of weight behind it now of just other people that have nothing to do with Beckhoff producing devices for it, and open source stacks for slaves, open source stacks for masters. So you don't have to buy anyone's kit. If you want to make your own on PCB level that does your own, there's an FPGA stack, so you can make your own sensor effectively that you can pull back into a centralized control system.
Well, I mean, for me, that just means that from a design perspective, I've always got escape routes. Because in the ideal world, a customer will tell you exactly what you should be designing, and all the hardware and all the specifications will be accurate, and so you can go off and design your system, and there'll never be any surprises. And then you enter the real world, and it actually having the ability to expand and scale. People, it surprises me that software engineers who design test systems don't design scalability into the hardware as much as they should sometimes.
Yeah, you're absolutely right. I mean, what's interesting is and I think this is a paradigm that I struggled with when I first started talking to Beckhoff, particularly, was we're used to doing everything in the software. You get yourself a high speed. Let's say we're looking at power, right? We're looking at input power in a factory, and we want to say, I think we've got problems with harmonics, and the harmonics is killing the drives. What I'm going to do, I'm going to get a really high speed analog to digital converter, run that, get my data. Right, now I've got my raw data. I'm going to do some power spectrum. I'm going to do some frequency analysis. Blah 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 blah. Right. The Beckhoff route is that we have a power module, and it gives you third and fourth harmonics. There's a whole load of outputs that come out of that, so you don't have to digitize it. The task is already done. It's been validated, and you just pull one of those modules. So I don't know how many modules we've got in NI. Maybe we've got for racks like this 40. I don't know, 40 different modules, something like that. Chris, how many? Just the Beckhoff ones. How many? 1,000. Right. Yeah. And that's just Beckhoff. So you've also got Circa Beckhoff and all these other boys that are making stuff as well. So
I mean, just I don't know, just throwing it out there with no foreknowledge. If perhaps there was another company here that you guys have been talking to, and they had a whole suite of like switching stuff and chassis, and they could talk, then you've got thousands and thousands and thousands of thousands. Just in case.
Yeah, exactly.
Yeah, no, I mean, I like it. I think that is my next job. I'm going to crack Linux. That's my this year job. Next year is Ethercat. It's going to crack Ethercat.
Well, there's I think if you enjoy the Fens and Huntingdon, there's a fantastic opportunity for you to be, sort of like surrounded by tons and tons of kit and try anything you want to see there. And the other thing is,
we've even got an explainer. If you want to have a go at that.
Yeah.
Yes, we're going to go over and have a look at the German gear now, I think, aren't we?
Yeah.
Right, come on then, let's go. So I'll tell you what, I'll keep it on just for fun.
Got your batteries?
Just to amuse myself.
I think one of the things that you want to, I think, we are. One of the things that you talked about, Steve, that I think is also relevant, and I think is cable management, right? Yeah. And that has been a constant thing within That's your environment. And it's like, how do we minimise the number of cables we're running? And obviously, I deal with vision. Vision is known for being nasty for cables because you've got, data cables, you've got triggering cables, you've got power cables, and it's a massive nest of crap that you have to deal with. And there are elements here which we can talk you through. And so this is Christian.
Hi Christian. So, right. Join I'm the best cameraman in the whole world.
Hi. Good morning.
Hi Christian.
Hi.
Right. So this is I've been told about this demo and I've not seen it working yet. So show me.
Switch it off.
Yeah.
The explainer system. So I don't know what you already talked about that.
Okay.
So there's like input the vibration on and it's filtering out the left turn and stuff.
So we better tell you what this is, Steve, to start with. So that, okay, so broadly speaking, it's a mover, which is effectively, if you drop your camera, you'll see that there's absolutely nothing other than pure magic holding it in the air. Right, these are actually running and flying like small flying carpets.
Little levitation.
Right, so these have got 6 degrees of freedom, so they do X, Y, Z, roll, pitch. So each one of those is a 6-axis motor system.
It's devilry, that's what it is.
It is devilry. So it can position to 5 micron-ish, and they make them up with payloads up to 4 kilograms. Accelerates at,
I think 2 meters per second.
4
meters.
4 meters a second, 2 meters 40.
Yeah, I don't know.
It's fast. It's very fast.
And this is essentially for moving stuff around factories.
Yeah, it's basically, we've been looking at a wide variety of different applications, including putting them in vacuums, which is one of the things we've been looking at.
Yes.
So it means that you've got non-linear movement. So if you've got mixed production batches, you can move things around in different ways. If something goes into a test station and fails, you can automatically send it for rework.
Picking and sorting. And
Yeah, exactly. So all this magic is being used as nothing more than a vibration generator for this other demo. And you can see we've got a trace here where we're pulling all of this data. We're reading the positions of these out in real time and putting it to that. Yeah, right. So this is using the ADS communication through string cap, which is showing where these things are going. And this is all Carolyn's fine work over the last 2 days. She's coded it while we've been here, right? So.
That's just showing off. It looks brilliant.
Okay,
I really like it.
There's actually 4 signals like X and Y positions for 2 movers, so that's color coded. And we can also have the 3D plot into the height information or whatever feedback. We can measure the consumed power per mover, the positions and the set points, so we can do almost everything. And this is showing the connection between the real-time processing here on the IPC and streaming to LabVIEW. And on the measurement side, we can also show how we control the settings in the I/O world. We go to let's pick the weight information. So this is a scale, and this scale is just holding some sweets, some signals, some changes here on the weight information, and this sensor is directly connected to one of these ELM high precision measurement modules. So it's a full-featured data acquisition device, and each of them is an EtherCAT device. So we got a chain I/O rack of different terminals. So starting with the coupler high voltage measurement, then we have a vibration IPE measurement for shock condition monitoring and so on. Then we got a featured like thermosensors and strain gauge based scale on one single amplifier, so 4 channels, and each channel can hold a different type of sensor. Then a supply module and also economy style, high precision but a bit slower, combined with standard. So this is an automation where we build around 8 million of these per year. So it's a quite a high volume. Then we also have a safety terminals in here, a bit of display terminals, and also go from the IP20 area arranged in the cabinets into the field, like IP67, protection against dust and water and so on. So you could also directly connect this sensor to one of these high precision measurement, but in IP67.
So just to reiterate what we're seeing here, you've got this lovely control part, which is essentially just vibrating the whole table. And then we're taking the measurement of the scale and you're filtering out all of that vibration and nastiness to get you a nice accurate reading.
Yeah, I can show
That's
you.
all been done in the hardware.
Actually in the hardware head, it's not in software. And we could, the demo we have here shows you can take the raw data and put it into LabVIEW if you wish, and then do something with it. Or you can use the onboard real-time filtering. And there's the filter 1, filter 2, and Christian does a very good set of training on all this stuff.
Yeah.
But yeah, I mean, I think probably over. Yeah.
The little things are jumping around.
Yeah.
But this is we are within 2 grams while the whole table is shaking, and I can also change, like trigger filter settings in the terminal from LabVIEW. Let's take from without any filtering to a Butterworth type of filter. You'll see some variations also depending on actual movement. So is it vibrating XY or shaking like this? So that influences, of course, the weight signal.
I've done what I've done, just take the auto scale off. Every time I do it, now I'm going to have to wait. Or clear it.
But in the meantime, we can do a Tara. So we can also send a Tara command. So we gotta go back to 0, and this is executed in the terminal. So the terminal does the Tara command itself, and we see that vibration on top here. So you see the different stages of what the explainer system is doing.
Yeah, that's quite a tough test actually, because your vibrations are going at all different frequencies, so the filter is going to be the top end.
Yeah.
So some bits are going to show up and some aren't.
I mean, when they were trying to fill in the lead forms yesterday, they had to turn all this off because you can't write on the table.
Yeah, I haven't seen the table jump from there. Come on, zoom in.
Here we go.
Boss, there.
There you go. And if we now let's put a few more sweets on here. You can see slide shift, but you also see an overshoot here.
Yes.
So that's not really nice, especially for weighing signals.
Yeah.
And for that we just designed another type of filter, wrote it, like send it to the terminal to process a bit different type of filter. It's called user-defined type of filter.
Yeah. Ooh, that's
So I removed one of the few sweets.
It's just like a rolling average with the nasties taken either side. That's my go-to. Yeah, I thought that. I mean, rolling average with the highest and lowest removed.
Yeah, I think Steve, you and I are working on the same theory. I mean,
It's actually a PT filter without any overshoot, really nice. Transfer function, also the step response looks really nice. And like, wait a few seconds, I can put a few more sweets on here and we see the different steps while this vibration or these disturbances are still incoming.
So this is tapping now, it's jumping up and down.
Yeah.
And that is rock step.
It's shaky.
That makes me very excited. I love it.
So this is within like 2 grams or so while the system is dancing. And I get like 10 grams each, I think, something like that. You see that within 1 gram, plus minus 1 gram. Now I add one of these. 1, 2, 3, 4, 5, 6, 7, 8.
So again, in a factory environment where you check counting things going on.
yeah, we'll check waiting.
Yeah. That's more than adequate because the noise is far below the thing of each individual item. So that's no room.
And we're talking about tiny sweets, right?
Yeah.
So, Christian, you had some examples about how this stuff works on conveyors in real time.
Yeah, this actually is an application where we show dynamic weighing. If you got food processing, like cutting cheese or cutting any other type of product that is being filled into a tray and then weighed. So there's a conveyor belt, and underneath, very similar to here, we got a load scale actually doing the weighing, but it's still there's sitting a massive 4.5 kilogram construction on top, including the motors. So the actual excitation of vibration is on the scale itself. And depending on the speed, also the changing, we see changing excitation frequencies, and we need to filter that out. So we can control the filter and adjust the filter related to the operating speed. So we get the speed higher, so we change the frequency in the terminal directly and still get super nicely filtered signals. And as we have a concept from fast raw data, and the first filter step and decimation in the second filter step, we can adjust for different, like general low-pass filtering to prevent aliasing, but we can also have moving average filter with a specified frequency to get this notch frequency, especially like the excitation frequency completely filtered out, and harmonics of this. So then you get a super nice flat signal.
Very, very cool.
And what's also interesting about this is that it's all the methods of actually executing this is based on standard theory of filtering. It's not custom Beckhoff stuff. You can apply the stuff you can apply the knowledge that you've got in an engineering degree about filtering. So I think that's worth knowing. And I think the two-day course that Christian gave us and a whole load of LabVIEW developers in the UK was primarily about the physics of filtering.
It's just a good skill. It's another one of these skills. I know I go on about it. Over years, this is why you can't just replace engineers, but you can gain all of this sort of skill, and I've seen people terrified of sort of noisy signals. And they just average the shit out of everything. And then you get lag and you get unrealistic. So the signal is not signal. For some of this filtering, you're still getting honesty in the signal. Averaging it to the point where it has no worth.
Yeah, exactly.
And it's good. I love it. That's a very good demo.
There's lots of information, even though we have a vibrating environment here, then you see, okay, what is my frequency? Do I see other frequencies which have not been there before? So that's maybe influencing from another machine, or maybe bad, but maybe a wrong speed setting or something. Could be anything.
Yeah, splendid.
We talked about one other thing, which was cabling, right?
Yes.
So one of the things that Beckhoffs really, I thought, made a difference with is simplifying cables. So what we have here, right? This is an EtherCAT P connector. So what that does is it's got an EtherCAT connection which is going in to our device, our field device, but it also generates power.
Yeah.
Right. Now that doesn't look particularly exciting until you start to see how big you can do that. Right. So we were talking to some of the guys about rail welding, one of their application. They need, I can't remember the numbers, but it's around 700 volts and a lot of amps, as well as EtherCAT, right? Because it has to move along these trains that weld these rails. So, to all intents and purposes, Beckhoff make a device, a cable that can do that in something which is about an inch in diameter, right? So that replaces a cable bundle, something like that. Oh wow! And it enables obviously there's a lot less copper involved, but it also means the complexity of managing these things is way more straightforward.
Well, in certain industries, cable management is the biggest cost. We've done maritime work.
Yeah.
You want to pass a cable between bulkheads, that's thousands of pounds. A new cable between bulkheads and shit.
Wind turbine testing. So if you have a rotor blade and you need to route out all the strain gauge wires from the blade tip down to the blade root where some instrumentation is being placed, those like distributed IOs can handle that quite easy. You just have a very short connection, like 30 centimeters to your sensor location, then route to the next EtherCAT P station. One cable.
This is why I'm very big on distributed systems. Signal cable. I like short signal cables. And computer.
Get it to the digital world and then transfer the data.
Yeah, it just solves so many engineering problems to do it like that. Right then, chaps. Well, that's lovely. I'll stop recording.
Yeah. No.